we're going to use something called a motion diagram to get a feel for position, velocity, and acceleration. A motion diagram is basically an indication of where the object is at a given point in time. And the way to picture this is if our object is in a dark room, it's completely black, you don't know where it is, and a strobe light goes off. You know what a strobe light is? It's a light that flashes at fixed time intervals. So the light flashes and we can see our object is right here. And then it goes black and we don't know where our object is. And then the light flashes again and now our object is here. And then it goes black and then the light flashes again and now our object's here. So if we were to put a dot where the object is every time the light flashes, we would get a motion diagram. So in this case, we would have maybe the object would be here the first time the light flashed. And then maybe it would be here the second time the light flashed. And then it would be here. You get the idea. So if this was the case, how would you describe this motion? What direction is the object moving? What's happening to the speed of the object? So by looking at this, we know that as the strobe light goes off, the object is moving to the right. And because we know the strobe light goes off at equal time intervals, we can tell by looking at this motion diagram that the object's speed is remaining constant. The speed is not changing. Now we can do a different one. If the first time the strobe light goes off, our object is right here, and the second time it goes off, it's here, and the third time the light goes off, the object is here, and the fourth time it's here, and the fifth time it's here, and the sixth time it's here. What can we say about the motion of this object? Moving to the right with increasing speed. Did you have other words you used to describe this motion? Words like acceleration. This object is accelerating. It's accelerating to the right. Acceleration tells us the change in velocity. And velocity tells us the change in position. As time goes on, our object is in a different location. The position is changing. So there has to be some velocity. In this case, the velocity did not change. The velocity was the same in each time interval because the distance was the same and the time intervals are the same. That means the acceleration is 0 in that first case. In the second case, as time goes on, the position changes, so we know there's velocity. And we know the position is increasing by a bigger amount each time interval. So that means it has to be speeding up. It has to be moving faster and faster and faster to cover a bigger distance in the same amount of time. So there's acceleration also because the velocity is changing. Anytime the velocity is changing, there's acceleration. And now describe the motion in this last case. So this object is moving to the right with decreasing speed. Were there words you used to describe this other than decreasing speed? Did you say there's acceleration? Or perhaps some students might say negative acceleration or deceleration? So we don't know if the acceleration here is positive or negative because we never defined a positive direction. We know that the acceleration has to point opposite the direction the particle's moving. So in the previous case, the object is moving to the right, and the acceleration also has to be to the right because the speed is increasing. The acceleration is the direction that the net force is pushing on the object. And if the object is moving faster and faster and faster, it has to be pushing it in that direction. Whenever these two point in the same direction, when acceleration and velocity point in the same direction, the speed is increasing. In the last case, the object is moving to the right, but it's slowing down. Why would it be slowing down? Because some force is pushing back on it. As it tries to move to the right, some force must be pushing back on it, causing it to slow down. That causes acceleration. And when acceleration and velocity point in opposite directions, the object slows down. We don't know if this acceleration is positive or negative because we never defined a positive direction here. It might be positive to the left. I don't know. We never defined it. But we do know it points in the opposite direction as the velocity. Now, what about the word deceleration? Deceleration really isn't terrible because we can all agree what it means. It means the object is slowing down. The problem with the word deceleration is that it implies that acceleration means the object is speeding up. And in physics class, that is not true. Acceleration means the velocity is changing. It might be speeding up. It might be slowing down. In fact, it might not be changing in magnitude at all because velocity is a vector quantity, which we will talk about very soon. So if the direction is changing, then the velocity is changing because velocity encompasses both magnitude and direction. So if the direction is changing, it's changing. And that means there's acceleration. In physics class, we like to say your car has 3 accelerators. The gas pedal makes it go faster. The brake pedal causes it to slow down. And the steering wheel causes it to change direction. Any one of those 3 things is acceleration in physics class. So when you use the word deceleration to mean slowing down, it kind of implies that acceleration means speeding up. So I will try very hard not to use the word deceleration, and I hope you do the same. Physics class is just like every other class you take. We have to be very specific about the words we use in our language. In everyday usage, we use words interchangeably all the time. I might say robbery and burglary to mean the same thing. But if you ask a lawyer in a court of law, they would probably tell you there's a difference between those 2 words. And everyday usage, we might use acceleration to mean speeding up, but in physics class, we know it means the velocity is changing. It doesn't have to be speeding up. It just has to be changing. So our position is typically denoted with some vector, and that could be a function of time if our particle is moving and it has a different position at different times. Velocity is the change in position or the displacement in some time interval. And if we want the instantaneous velocity, this would be the average velocity. If we want the instantaneous velocity, we take derivatives. The derivative of the position function with respect to time. And as we've said already, acceleration is the change in velocity over time. That would be the average velocity, and the instantaneous acceleration would be the rate of change of the velocity with respect to time, dv dt.